It was just enough that you saw it, that's all.
Yeah.
Okay, we'll have a look at the next lesson now. So, last week when we were doing derivatives, what does the derivative represent on the graph? Yeah, the slope, isn't it? Yeah. So now what we're going to look at is what does the integration represent? And some people know this already, it'll be the area. But let's have a look at that for ourselves. Okay. So let's imagine, for example, we have some function, let's just call it fx. And we want to figure out what exactly does it mean on the graph to calculate the integration. Are we ready here? Yes? Yes? Yeah. So, I want to show you that we can think of antiderivatives as representing area on the graph. So, let's imagine I have an A and a B, and I try to calculate the area under the curve between A and B. Now, the problem is that this part here is curved, right? So what I could do is if I make this, let me just call this A for a moment, let's just call it X, and let's just call the B X plus H. So I'll make this distance here really small. Yeah? That means if I draw a straight line, I know it won't be perfect, but at least it won't be too bad as a approximation. So I'm looking to try and calculate the area here. As long as these two are close together, you can see it's not so bad to draw this shape. So let's try and calculate a formula for the area. Well, there's actually two shapes here. Yeah. We can think of it as a triangle on the top and a rectangle on the bottom. How big is this? And I'll give you a hint, it's the same as this. And this is our x. So what's this here? This is f of x, f of a, f of x. And then what's this height here? The next one. F of x plus h. So this height of the rectangle is f of x. And what about the height of the triangle? Yeah, x plus h minus f of x. So now we can calculate the area. It will be the base. How big is the base? H times the height. F of x. This is h and this is f of x. And now the triangle. Half the base times the height, which is f of x plus h minus f of x. Yeah. Because it's from x to x plus h is what the two are here.
Then why is the height of the x plus h?
The height?
Yeah.
You mean here?
No, like on your y-axis when you were doing.
Oh, f of x plus h and f of x.
No, if the base is h.
Yep.
If the base is h, then how come when you're doing like the height, like everything up, it's x plus h, like x plus the base?
Well, what I'm saying is this value here on the axis A, I'm going to call it x. And this value B, I'm going to call it x plus h. So on the x-axis, these are x and x plus h. The distance between them is what I care about. The distance is h.
So how did you get the height of A?
This f of x?
Yeah.
Are we happy saying that I'm calling this x here?
Yeah.
So by definition, f of x is the height. You know, like f of x equals x squared? So if I call this 2, what's the height? Yes, just like that. Yes.
The f plus x is the height,
Yes.
and the f plus x plus h is
The height.
plus the height.
The height here is f of x, and the height here is f of x plus h.
Okay.
Guys, you're forgetting basic stuff because I'm not using numbers, that's all. This is not numbers. Yes. No, you're all making that face like, oh, this is hard. No, it's just your sleepy face. Yeah, okay. Continuing? Yes, okay. So, here, let's simplify this a little bit. H of f of x plus a half h f of x plus h minus a half h f of x. So, I can put this one with this one, and what am I left with? A half h f of x plus a half h f of x plus h. Yeah, and what can I factor here? A half h, isn't it? Yes? A half h. Yeah, f of x plus f of x plus h. Yes, do you? What are you asking me? No, I'm just trying. Just watch and see what happens. Okay. Right. Now you see, it distracted me now with what I'm doing next. Sigh. Right. Oh, dude, you've totally distracted me. Now I can't remember what I'm trying to do. No. You don't know what I'm trying to do. I don't know what I'm trying to do. Can you just come back from something there? Alright, forget this. I'll do it a different way, because I'm getting confused this way. Now, I'll do it again. This time, only ask me a question if it really is a question. Okay? Okay?
Why are you looking at me? It was too bad distracting.
You too. Right, so I'll do it again. It's the same letters, but I'll just do it a little bit differently, so it's a little less confusing. Okay. So again, let's draw my curve, and I'll call this one here B, and I'll call this one here A. Did you just say yeah, as if now it's all suddenly better? The only difference is I just drew my curve slightly different. It's like, oh yeah. Oh no, I'm going to get it this way now. Right. At this point here, I'll call this one f of A. I'll use the x and the x plus h later this time. And what would this height here be of this one? F of B for this one. Is that okay? And what I'm looking to do is to calculate the area here. No, please. Please don't distract me, please. This is quite difficult. I need to focus on this. Okay, so I'm looking to calculate the area here. Yes? Okay. So, what I'll do to try and help me get that is I'll make a special function here. And I'll call this x, and this is 0. And I'll call this function a of x. So, for example, if I say a of 0, what that means is no area. If I say a of 1, that means the area from 0 to 1. And then a of 2 would be the area to 2, for example. Do you get what I'm saying with the a of x? It's the area from 0 to x. Yes? Okay. So what I'm going to do next is I want to calculate the derivative of this area function. So from first principles, what is it? A x plus h minus a of x all over h. Yes? And now, we need another little bit of a hand. We have to decide again. We need a way to calculate a of x. So that's what I was doing a minute ago. We'll draw the shape in. So it's roughly like this. Now, I know it's not exactly like this, but it's roughly like this. So this is 0, this is x. What's the height here? What's the height here? F of 0, very good. And then the height here? Of f of x. Oh, sorry, 0, thank you. Now, what's the height of the triangle? F of x minus f of 0. Yes? Okay, so the area here will be half the base. So what's that? Half of x times the height, which in this case, what's the height here? The height of the rectangle? Oh, sorry, I'm so sorry. So sorry. The base, the rectangle. X times f of 0. Okay, now onto the triangle. Plus a half of x times fx minus f0. You need to focus, because if I'm having trouble keeping track of what's going on here, you're definitely having trouble. So no talking, just watching. You got that? Okay. So I'll just write this out again a little bit neater. Ax equals x f0 plus a half x fx minus a half f0. So what would ax plus h be then, if I just replace the x with x plus h? That would be x plus h f0 plus a half x plus h f x plus h minus a half f0. What I do now is I take these two and put them back into this. Yes, I know it's going to look ugly. Right, so on the top is a big fraction, on the bottom is just a h. So on the top is all of this minus all of this. X f0 plus h f0 plus a half x f x plus h plus a half h f x plus h minus a half f0 minus x f0, ran out of space, minus a half x fx plus a half f0. I know, it's terrible. Right, but we can cancel lots of stuff. This cancels with this. Have I got another one? These two add together. So I'm left with x fx plus h. So this is good and this is good. Anything else cancels? Oh, this one here minus cancels with that one there. So what am I left with? This one and this one. Yeah? Okay. Plus h of f0 minus a half x f of x. Yes? All over h. Can we still see? No, forget it.
That's why I ripped it out right now.
I just realized this is only going to get worse. I'll jump to the final result. Yes. Therefore, area equals integration. There's some details here which are missing. Yeah, a lot of details. No. This is why I'm skipping it. If you watch the video from last year, there was less distractions, so the proof is clearer in last year's video. But I'm not so worried about this because it's not even something close to being on the exam. You just need the result. Okay? So at the very least, result here.
So basically, everything you disclosed for the last 15 minutes is useless and it's the only thing that we can.
No, I didn't say it was useless. It was good to see these things, even if you didn't see all of it.
I meant for the exam.
For the exam, yes, useless. For your own personal growth and development as a human being,
Oh yeah.
some value there.
I use it. Oh my god. I'm so happy.
You've learned an important lesson, you know, when to give up. This is important in life. Sometimes you just have to face facts and say, you know what, it's not worth it, I've just given up. It's true. You'll learn this soon enough. Okay, so can I have a look at actually doing some examples using this result? So here we're saying that integration represents area. Yeah? So let's do a simple example and then we'll make them a little bit more difficult. So here's our first example. Yes? So let's pick a very, very, very simple function. A straight line like this. And this is just simply fx equals x. And I want the area from 0 to 1. Now we don't have to use integration because we know what the answer is. What shape is this? It's a triangle, yeah. And what's the base? 1. And the height? 1. Yeah. So what would be the area? A half is the area. Yes? So what we should get when we use the new rule is we should get a half. So let's test it out. The area equals 0 to 1 f of x. What's f of x here? X. dx. Let's see if we get the same answer. So if I integrate x, what do I get? X squared over 2. 0 to 1. So if I put 1 in, what do I get?
1 of 2.
And if I put 0 in?
0.
So my final answer?
Half.
It's a half. It's the same answer that we get when we just use the simple formula. But of course, we're not using integration for problems where we know the answer like this. We're going to use it for more difficult shapes. Can I scroll down a little bit? Yeah. Right. Everybody tried this one. We have this shape here. It's a quadratic. And again, I'll make it 0 to 1. And the function is x squared. And I want the area here under the x squared. Okay, so try this one. So previously we had no way of doing this because it's not a shape we know. But now we can use integration and we can calculate the area. Okay, did we get an answer? So we have integrate from 0 to 1 x squared dx. This will equal x cubed over 3, 0 to 1, which will be 1 over 3 minus 0. So the answer is 1 over 3. Okay, I'll give you another one. I'll make it a little bit more difficult now. So I want you to see what happens if you try to do something like this. Let's say 1 to 2. No, actually, let's make it a little bit. Oh no, okay, 1 to 2. 1 to 2. And I wanted to see what happens when you integrate this. And the function is x squared minus 3x plus 2. Try this one. What did you get? Yeah, let's look at what happens here. So when we integrate, we get x cubed over 3 minus 3x squared over 2 plus 2x. And we have to put in 1 and 2. So I'll put in 2 first, and I'll get 8 over 3 minus 6 plus 4 minus 1 over 3 minus 3 over 2 plus 2. So this will be 8 over 3 minus 2. Yeah, minus 1 over 3 plus 3 over 2 minus 2. So this will be, let's see, 8 over 3 minus 1 over 3 is 7 over 3 plus 3 over 2 minus 4. I suppose I could just use a calculator. But okay, fine. What is it? Minus 1 over 6. Now, this is a bit odd because we have a negative here. Yeah, what's the idea? Well, what's the reason for the negative? Yeah, it's because it was underneath the curve. That's why the area came out as negative. But area should only be positive. So you don't say the answer is minus 1 over 6. The area is 1 over 6. So you have to be very careful here because it basically means that if f of x is below the axis, the area is actually minus a over b f of x dx. So you have to fix the sign at the end. Just be careful with that. And if f of x is above the axis, no need to fix the sign. You just keep it the same. Yeah, you can put the minus at the outside at the beginning if you know it's below the axis. So we could have said here at the beginning minus. So it would have a minus, a minus, a minus, and a minus here, so the answer gets fixed. So if you know it's below the axis, you can put the minus at the start. The answer will become positive at the end. Now this actually becomes a big problem if it gets mixed. Can I show you what I mean? Can I go down? Yeah, it's fine, yeah. Can I go down? Yeah. So for example, if you have something like this, let's say this is 2 and this is 4, and I want this area. This is negative and this is positive. And the problem is we can't mix this. We can't mix it like this. This point here is 3. So please note the area is not 2 to 4. Yes, what we need to do for problems like this, the area is 2 to 3 f of x dx, but because this is underneath, minus, plus 3 to 4 f of x dx. So if the area is a mixture of negative and positive, you must split it into 2 problems. You must split it into 2. Yeah. Now we'll do more of these, but before we finish, it's just like I don't know when to quit. I'm going to go back to the proof, okay? Yeah, that's right. Deal with it. So just write this one down. We'll do more of these in the next class, but I'm going to finish on the proof, okay?
Can we do the proof in the next class?
We cannot. I won't be able to sleep tonight if I don't do it now. Yeah, but I just don't know when to quit, okay?
But you told us that that's
I just don't know when to quit.
But you told us
I know. Right, can I scroll down? Okay. Right, so just relax, stay calm, okay? So the first thing, again, I will call my a function the area from 0 to x. That stays the same. Got that? And this time, what I'll do is here, this is x plus h, and I'm going to look for this area. And I'm going to call this area, because it'll be small, I'll just call it something like small, no I don't, P, delta, what about delta A for small area, yes? Now, this small area would be area from x plus h minus to x. Because if you think about it, if I go from 0 to x plus h minus 0 to x, what am I left with? The piece that I want. Yes? If the h is really, really small, I can draw a line from here to here and make it this shape. So what I can say is, this is roughly a rectangle plus a triangle. Yes, so that's h times f of x plus a half h times, what's in here? F of x plus h minus f of x. Okay, now this time what I'll do is I'll divide both sides by h. So here what am I left with? F of x plus a half f of x plus h minus f of x. And here I have a x plus h minus ax over h. Is that, you got that? Yes? Okay, now, next what I'll do, let's see, base, okay. So now I make h really, really small. So what happens when I make h really, really small? What does this become? If I make, what does it become? What happens when h gets really, really small? What does this become? You should recognize it as something familiar. What is it? Oh, no, come on. You should recognize this. In your head. Oh, yes? No. I'll give you a little hint. If I wrote f of x plus h minus f of x over h. No. Derivative, first principle. Yeah. Do you remember first principles?
Yeah.
Yeah, so this becomes actually the derivative.
Okay. X, yeah. Minus the x. Oh no. That's zero.
Yeah.
I'll stop.
Yeah, you're not, it's not helping you. Right, so what am I left with here? F of x, and then when h becomes 0, what do I get here? No. F of x, well I do actually here get 0, because this will be f of x minus f of x. So together this is 0. So I get derivative of a equals f of x. Yeah? So derivative of a equals f of x. So what I'm saying is, if I differentiate a, I get f of x. So then if I anti-differentiate f of x, what do I get? Area. So I'm saying that the antiderivative of f of x is equal to the area. Now what happens if I put in limits? A to b, f of x dx. That would be ab minus aa. Yeah, so what will this be? That would be the area from A to B. Now I can sleep tonight that you've seen this. Yeah, if the question is this on the exam, the answer is no. If the second question is, why are you doing this, Stephen? The answer is, it's just something wrong with me, I have to, okay? Right, so the question is, you actually want to see this? Alright, okay. Oh, no, to be clear, I'm not doing this for you to understand anything. I'm just doing this to do it. Yeah.
I know, but
Okay.
Why did you?
Which part?
because of first principle that becomes
The derivative.
Oh yeah, no, I remember. The very first sentence.
Yeah, remember for first principles we said delta y delta x was f of x plus delta x minus delta x over delta x. Or the other way we wrote in class was f of x plus h minus f of x over x plus h minus x. It was when we were doing the slope. You remember doing this?
Yeah.
I can't quite tell from your.
The very first one.
Are you telling the truth?
Well, yeah, I understand like what you did at the top, but then I don't know what you're doing when you come from the other end.
Here to here?
Yeah.
I'm just saying we wrote it two different ways in class. We wrote it like this when we were using, remember, x and f of x, and then this point here was x plus h and f of x plus h. Did she ask you, did we do this? And you answered, yes we did? Or
I remember the top one like really well, so pretty cool, but then I
not the bottom one? Really? Because I think I would have done more of them this way than this way. Did you miss this class? This explains it. Okay, so watch the video, yeah. We have a class tomorrow, is it one, don't we?
Yeah.
One or two? Anyways, wait, I haven't really done any examples here, so what we'll do is in tomorrow's class I'll just do lots of examples and then you can practice some and then we'll move on to probability after that. Okay, so the homework is to finish what I gave you earlier.
Yeah.
But there's no homework from this. We'll continue it in the next class. Okay? I don't know what you're asking me. Yes. Yes.
Thank you.
Yes. Oh, sorry.
I'll wait.
That sigh was a bit too loud, wasn't it? Yeah.